Good morning, friends. Now we are going to discuss conservation of mechanical energy. It's a 6.8. It's a conservation of mechanical energy. It's a 11. It's a conservation of mechanical energy. What is the law of conservation of energy? We all know the total energy of the system always remains constant. But here, this is the statement you learn in lower classes. But let's see what is extra in this one. The mechanical energy, the total mechanical energy of a system is conserved if the forces doing work on it are conservative. See that, the statement which comes. What is important in that one? Forces doing work on it are conservative. This is important. So total mechanical energy of the system is conserved if the forces doing work on it are conservative. This becomes the law of conservation of mechanical energy. Let's discuss it, and for simplicity, we are taking one-dimensional motion of any object. We all know work energy theorem, change in kinetic energy is the work done. It means that K final minus K initial is work done. Similarly, there is negative of change in potential minus delta V is equal to work done, or work done is negative change in potential energy. So we get it, W is equal to V final minus, here suppose that there are two things, Xi is initial position and Xf. So Vxi is the initial potential energy, Vxf is the final potential energy. Therefore delta V is equal to Vxf minus Vxi minus delta V is equal to Vxi minus Vxf. This is also equal to work done. From this 2-1, we can show that there is K final minus K initial is equal to Vx initial minus Vx final. This is one thing. Another thing, we can write it, this and this are equal. Therefore, change in kinetic energy is minus change in potential energy. We can take it to this side. Change in kinetic energy plus change in potential energy is 0. Or we can write it also, change in K plus V is equal to 0. Change is 0, it means that K plus V is constant. Constant is K plus V, kinetic energy plus potential energy of the system does not change if forces doing work are conservative. This is one. From these two cases we can write, that is K final minus K initial is equal to Vxi minus Vxf. K final plus Vx final is equal to K initial plus Vx initial. Kinetic energy plus potential energy at final position is same as that of kinetic energy plus potential energy at initial position. And it gives us the law of conservation of mechanical energy. This is called as kinetic plus potential energy is known as mechanical energy. Now, this one indicates that at different locations, kinetic energy can change with position. Potential energy also can change with position. But what remains same? That is, kinetic plus potential energy remains constant. There is no change in mechanical energy. And this is called as law of conservation of mechanical energy. We say that total mechanical energy for system. Total mechanical energy for system. For a system is conserved if forces doing work are conserved. This is the statement of law of conservation of mechanical energy. And from this one, we define what is the conservative force. It gives us a definition of conservative. It gives us definition of conservative forces also. What is the conservative force? First one, the force Fx is said to be conservative if it is derived from scalar quantity like a potential energy. It's important one. This is called as a conservative force if it is derived from scalar quantity like potential energy. It's the first definition. Second one, that is the energy or work done is path independent. If the work done by the force is path independent, that is it is called as conservative force. Third one, the force is said to be conservative if the work done depends only on initial position and final position. It depends only on initial position and final position. It only depends on initial position and final position. We can discuss two more particular examples for this one. One is the free fall under the Earth's gravitational field, and second one is a spring force. Let us see. It's a free fall we are discussing. When the mass m is released from certain height. When mass m is released from certain height, then what happens is this. Here is x. This is. It is released from certain height h. At this point it is h. So it is origin. This total height is h. This is called as vh. This is final on the ground. This height is h minus h. Now mass m. Mass is m. Acceleration is g. Let us check at different points. At highest point O, it is at this point, at highest point O, there is VO is equal to 0. Therefore, kinetic energy is equal to 0. H is equal to capital H. So, potential energy is mg capital H. Mechanical energy is K plus V, which is mg capital H. Equation number 1. Now it comes down up to this one. When it is at final one, let us see at final position. V final is equal to under root 2gh. But h is equal to 0. We can even calculate. So total energy is kinetic plus potential. That is again half mv final square plus 0, which is equal to half 2gh m, which gets cancelled. That is again. So total energy is mgh at this point. Final. Now by this one we can find out velocity at this point h. What is the velocity at point h? Vh. We can find out either by considering. So law of conservation of mechanical energy suggests that everywhere energy is mgh. Let us consider at this point kinetic energy is half mvh square. Potential energy is mgh because it is height h. So total energy here is half mvh square plus mgh. And from law of conservation of energy, that energy is mgh, capital H. These all energies, this T and this T, they are equal. At all point, total energy is same. So this one we can equate with mg capital H. So let's see now. Half mvh square is equal to mg capital H minus mgh. So half mvh square, mg is common, h minus h going. Vh square is equal to 2g h minus h, or Vh is equal to under root 2g h minus h. Vh is equal to 2g h minus h. This is by using law of conservation of mechanical energy. We got it. Now, kinematical equations we can use it. Here, initial velocity u was equal to 0. Here it is Vh and it travels distance h minus h. Initial velocity is 0, final velocity is Vh and it travels distance h minus h. Apply kinematical equation. V square is equal to u square plus 2as. V square final is equal to 0 to g. S is equal to minus h. We get it as 2g h minus h. This is by using kinematical equation. This is by using law of conservation of mechanical energy. Both the results match with each other. We can say that the gravitational force is conservative force. This proves that, this complete discussion proves that gravitational force is conservative force, and in this case mechanical energy at all point remains same. That's all for this. Thank you.